September 21st, 2020. Guys, you're looking at the JPL model of 2018 VP1. That's the asteroid that's going to approach the Earth very closely, if not a direct impact, on November the 2nd, the day before the election. I've got this backed up a couple of days on the time here just so you can see it. This is showing October the 19th, just so you can see the separation here. And what you've got is the Earth is in blue, 2018, VP1 is in the white orbit. And I'll step this thing forward to November the 2nd, which is showing here the 2nd at 0 UTC time is the closest approach, 0.390 E-3 AU. This hasn't changed according to the JPL, but the European models are a little different. It's showing 3,632 miles, but that goes from the center of the planet. Remember the orbital mechanics? So that's about a 320-something a mile problem. In other words, at the minimum distance, it's going to strike the Earth. It's just simply the Earth is wider than the distance that this asteroid is approaching us. Again, 3,632 miles. But this is NASA. Now, I want to go to the NEO-DYS system and a more European model, and it shows a much closer approach than this. Even though this is close enough, it is the minimum distance figuring. So, but let's look at the European minimum distance, and you're going to see a big change. Now, again, this is the NEO-DS System -2 2018 VP1. The section we want to look at is right here, and that is November the 1st, 0.996, now, just before midnight UTC time. And your minimum distance is different, 0.0000140. And guys, if you put that into your AU calculator, it'll show you 1,301 miles. You got to remember, again, the Earth is 7,917 miles wide. Half of that is where you get your 38. So at 1,300 miles from the center of the planet, it's a much more likely scenario that it will strike the planet. Now, it's not as large as a Cherenkov meteor, maybe about 12 feet. I think it's around 43 cubic meters. But guys, again, that is the size from the JPL systems. So if they're off this far in their astronomical units, as far as the distance from the center of our planet, are they possibly off also on their radar imaging of the size of the rock? But again, this will not be probably an Earth-striking asteroid. It will hit our atmosphere, and you'll have a mid-air burst. And it could create some problems with that depending on if it's over a populated area. If you remember the Cherenkov meteor, it was about 3 or 4 times that size, but it exploded in a magnificent fireball. I think over 3,000 buildings had damage. A lot of people got hurt. So again, I just wanted to update it. The NEO-DYS system has this thing much closer. They're not updating the size, but they're talking about a 30 magnitude, which again would be about 43 cubic yards, if you want to put it in that way, which would, again, it would be an aerial burst and possibly a shock wave. Not as big as the Cherenkov in Russia, but it's very interesting that this is saying VP1, because sometimes when they number it instead of just VP and they say VP1, guys, there may be more than one object. You could have VP2, things like that. Notice this, a JPL model database shows, again, this is JPL, the distance of 0.000039 AU, or 5,800 kilometers from the center of the Earth, which is less than 6371 kilometer radius of the Earth. You see what I'm saying? So people say, there's some guy that comes on, I don't know who it is, every time I do an asteroid update on this particular rock, says your calculations are off. I'm telling you I'm not. If you want to come in and say that, please put the math in to your comment, okay? And enlighten us, if you don't mind. But again, this is orbital mechanics. They measure the distance from the center of the Earth. And so we got a much larger, 3 times higher chance of impact on that time. Now, let me say this about the Cherepovets meteor in Russia. We were watching another asteroid come in, and it was televised on certain channels, and it was really talked about a lot. But the Russian meteor hit at the same time, but on the other side of the planet. So these things do travel in pairs. I'm not saying this one is, but we do know what some of the other people are saying about it. As it gets closer to that time, we may get a recovery from NASA. Recovery is that they haven't seen it since 2018, okay? And this is 2020. That's how it got its name, 2018. So they're waiting for radar to recover the object, get a better look, because it's coming much closer than it did in 2018. The problem with that is it's coming from the sun. And if you noticed in the JPL model at the beginning of the video, if you want to back it up and look at it, it was striking the Earth from the sun side. It was inside the orbit of the Earth, so it would be almost at sunrise on that particular section of the planet. And if you want to go in and put November the 2nd at 0 UTC time, look at where the Earth is at that point, you may come close to figuring this out. We'll look at it closer and do some more calculations. I'm still waiting on, again, what's called the recovery of the object, and we will have more info then. But again, I was asked about were there any updates, and this is the only one I found, guys. But it's a heads up. Be safe.